Let's continue talking about arrays. By now, we know that arrays are one of the most important objects in engineering because we can use arrays to form vectors, matrices, to store data, information, etc. And we've mentioned so far that to create an array, you have to declare the type of information that you're going to use. So the array in this example is going to have 5 positions, and all the data or objects in the array are going to be ints. Therefore, you declare int, the name of the array, the size, and then you populate your array. This line is exactly how you declare an array in C and C++. If one of these numbers is going to be a float or a double, and everybody else is going to be an int, then remember the rule, the key, is that all the objects have to have the same format, the same structure. Therefore, if only one of them is a float or a double, then you declare it as a float instead of an int. And the advantage of this particular array being int is that you have less space in memory to worry about. So let's look at the example right here. We go to the and we are going to create a script that will let us print an array. So by now we more or less know how to do that, but after this example you should be able to create an array pretty easy. So first of all, we're going to include a library that will let us have a printf statement to print to screen, and that is going to be in the C standard input-output library. There are a few of them that you can use, but this one is common C and C++ library for that. And we're going to create a main function, int main parentheses, then open and close curly brackets, return 0. This is all we need to create our main function. You know this by now. So int is going to be the type of array. The name is going to be array. It could be any name. And the size is going to be 5 for this example. Equals, and you use open and close curly brackets to define the array. And it could be anything. So this one is 0, 2, 3, 4, 5. I think that this does not correspond to this. There's a typo here, should be a 1. Let's have 0, 2, 3, and 4, and 5 to see what it is. Then this array, you can print it or you can use it. I want to create a for loop to access each value within the array. So my for loop is going to use an int I as the iterator, which is going to be start in position 0, which is the first value in my array. Remember that C++ and C start from 0, and Python also starts from 0. Other languages start from 1. So my first position is position 0. I'm going to say I is less than 5 because I have 5 positions. Or I always like to do this a little better in case you have to do it dynamically. So int size array equals 5. And let's use this, because then you can use different declarations here. And then semicolon, we're gonna say I++, and then we should be able to print our information now. So we just want to print each number within the array, so print %d because it's an int, and then array and position I. Positions are with straight brackets. Enter, and we should be able to run this. And we're going to say week 6. week 6 executables. Go there, array of ints, and we have an error. Yes, we have an error because we don't need this parenthesis right here. We need this parenthesis right here. And if we print now, we have another error. It's because the name of the array is array, not array. And we have another error because we say printf. Print doesn't exist, it's printf. And if you print it, then you should have 0, 2, 3, 4, which is each value in the array. We can make this better by putting comma. It's a little more organized. And then 0, 2, 3, 4, 5, etc. So this is how you create your array and how you print it. Let's go back to the PowerPoint and we see that there's something called primitive or C arrays. And this is basically what we're dealing with. Primitive or C arrays are arrays where you can use a pointer to access the information. So right now, what we have is that we declared an array and we're saying that it's called array or IA, whatever name you want to say, and it's 5 positions. The first or index or the first position is position 0, and the 5th position is position 4. And that is because this is 0, 1, 2, 3, and 4. Okay, so you can create a pointer that points to the array and accesses the positions. That is very useful because you don't have to copy. If your array is 1 million elements, you don't have to go and copy the whole array. You only point to it, and then your code is much faster. So we can first show you that when you save an array or a value in memory and you don't initialize anything, you don't say that this is 10 values, but I know each value. The compiler is going to assign the array the values that are already registered in memory. So let's take an example. Let's take this example and see what I mean. So if you create another script where, and actually we can copy most of it. Say let's copy this. We bring it here, and instead of standard C, we're gonna use the C++ library that corresponds to the same library, which is standard input H. And so in either, both of them contain printf. So I'm gonna give you different flavors of what libraries you can use to access printf. And then we're gonna say main, size of the array is 10, trying to get to this code right here. And I'm gonna say that my array is named array with size array, but I'm not going to initialize the array with any values. Say I forgot or I don't know, but I want to use it later, and I have to still populate or assign the values to it. If for some reason I forget later on to assign values to it, the compiler is going to assign values to those locations in the following manner. So let's save this array to memory. And when you run it, notice that, let's do an end line here. Let's close this and let's do /n. So jumps line, okay? Notice that if you have if you didn't assign your values to your array, the compiler is gonna say, okay, you created an array size 10, which is this guy. So you have 10 elements in this array, but you're not telling me what those are. So I'm gonna allocate this array in memory, and for now, the values in the array are gonna be whatever it's in memory. Another thing I would like you to notice is that these values are not the same as the values that obtained the first time I ran this code days ago. And that is because since then I've turned off my computer or restarted the computer and I've used the memory for other stuff. So again, since I didn't initialize the values in memory, the compiler is going to assign whatever is the in memory at the current time. So notice that some of them are completely different, and that is exactly what I mean. So if you don't have your values for your array, make sure that you have to assign them eventually when you use the array, and if not, then you're probably going to have some errors when you access your array, or perhaps you don't need an array at all. Okay, let's go back to the part presentation. We're going to then use an example, create an example where we have a function that is going to pass an array into the function. So how do you use arrays with functions? Let's create that example right here. We're going to create a new code, new source file, and we're going to use, maybe we can borrow some stuff from here. Let's borrow, seems like, no, we're going to use cout. Okay, so since we're going to use cout instead of fprint, then the library that we need is the input-output stream. Input-output stream. Remember that this one doesn't have a .h. And using namespace standard for the cout. And now we can create our main code, which is called main, open bracket, and return 0, which is 0 is an int, and we're saying that main is going to return an int value. Okay, so we're going to say that we're going to have a vector of vectors, an array of 2 by 2, which is going to be type a double, and the name is num. So we're going to have in one direction 3 elements, and the rows is going to be three rows and 2 columns. So 3 by 2. And we can define it now with open and close curly brackets. And we're going to say the first, the second, and the third rows. Since it's 3 rows and 2 elements and it's type double, we can put decimal numbers there. So we're going to say 3.12, 4.0. Then we have 9.1, 5.5, and 7.1. So that's 7 and that at 1, even though it look like int, they are really double. So that's my declaration. It's called num. And what I need to do next is that I need to create a function that is going to call the name is going to be display, and I'm going to pass my array. Okay, so let's create the function. The function is going to be up here. So I am going to print the array in the function, therefore I don't have to return anything to the program. So the function could be a void type that doesn't display anything. And we can say double, and there is going to be, even though it's called num in the main program, I'm going to pass it as n or mat, and is going to be 3 by 2. And we can create our function now, which is, we're going to use 2 for loops for that, because we have rows and columns. So for, let's say int I equal to 0, semicolon, for I less the values of the rows are 3, comma, e plus, so it's going to be I plus plus because it's 3 rows. And then we're going to do exactly the same for the columns. We're going to print 1 row and 1 column at a time. So instead of I, we're going to say j. J is less than 2, and j. And then we're going to say, we said we're going to use cout. So cout is going to be, seems like I am printing the, let's see, num, and then I'm going to pass the I, and then I'm going to close the matrix position here, open again. Let me see what I'm passing here, and J. Okay, so I'm going to pass J, and then I need to close that again. So close J, and then I'm gonna say equals. Okay, and then now is where I write my mat. So the name I passed into my function was mat. Therefore, I'm gonna say mat ij in here, and then I have an end of line. Correct. And then I have an end of line. End of line. Enter. Okay, so I should be able to run this. Let's see if I have any issues, any problems, any compiling errors. So let's say array in function. All right, an error cout is passing where? Let me see. End of line. Yes, that's all I wanted. So first of all, let me see if this part is pretty confusing. So let me see if I can do cout without any issues. First of all, doing this compile, and it seems like I have an error here, which is 3,2, and I have 3 rows and 2 columns. And what is the issue? Let's see. Run again. What is this issue? I can't read. Okay. Oh, I see. It's saying that before this I have, oh yes, it's because all this is within this. Right. Okay, so if I run it, I'm displaying the values of cout mat. What? Yes, it's because here is where I put I comma j. There's within the for loop, and I have 3 point. Okay, so now I'm displaying the matrix. Excellent. Okay, so let's try and display the whole line that was giving me issues before, and I don't have any more. So let's do it again. So matrix, it's gonna be called matrix, and open, and then we're gonna say position I, and then close bracket, open bracket, and then pass position J. I think it was the next line. Yes, position J. And pass another comment where is me closing the position. Okay, let's see if now it runs. Okay, good. Oh, and I forgot the equal sign. It becomes a little confusing at the end, printing all those variables. No compilation errors. Run it. Yeah, so metric at 0, 0 is 3.12, which is what we have here. Let's make this a little smaller. So 3.2, and then I have a 4, and 0, 1, and 1, 0 is 9.1, and 5, 5, and then 2, 0 is 7, and 2, 1 is 1. All right, so we finally got this code to work. And this is how you pass a matrix into function. Also, I would like you to see that another way that you can do your function declaration is by having a dynamic size. So for instance, in this case, we can go ahead and see that the function also void because it's going to print the values. It passes the array as an empty or as a dynamic array. So basically says, I'm not going to give you the size right now, but you have a way to put the size with the matrix as well. So in other words, notice that here size is 5 and you pass this 5 in here, right? So if this is 10 and this changes to 10, then basically this will know that okay, now it's a 10. And then that way you can pass your array as an empty, as a dynamic array, and then declare your size as well. And this size is what you use for a for loop or for anything that you want. So by now, we know how to create a function and input an array. This is exactly the same thing that we just did. We created a function called mark or scores or whatever name you want. And the goal is to be able to create a function that takes that array. So this is exactly the same. With the int main function, you create your array, this type int, and then your function called display, you pass the array. But notice that here you don't have to pass the size or anything. It's when you take in your matrix that you declare the type and the size. And then you just basically have to print each position if that's what you want. This is exactly the same. It's just a different set of values. So don't worry about doing every example as long as you understand the concept. And it would be nice to practice to ask the user for the size and ask the user to input the numbers for the array, and then have a function that takes from the main program the matrix and can print them. So basically take the example that I just wrote on div++, where you can do a cin for size, and you can use that size to create the matrix, right? Or a vector, it doesn't have to be a matrix. So say vector type size, and this goes into a function. So by now, you should be familiar with creating arrays dynamically and statically, but it's not very convenient to have to create an array with 5 positions so sometimes you don't know the size of the array until you're into the problem. So there's a library or a template in C++ called vector, and this is very useful, and this is one of the most important things in C++ for engineering. And vector is part of the standard template library, the same way that we use a standard template library for cout. Vector is part of that standard, and it will let us create an array and treat it as a vector. So as we saw before, this array has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements, but still the index starts from 0 and is going to be n minus 1, the last index. So let's use an example to understand your vector library. Let's go to dev++ and create a new file, and we're gonna do, let's see if we can copy anything from here. We're going to use input output stream and standard namespace. So let's copy those two. But also we're going to use other libraries, other headers. So we're going to use a brand new one, which is called vector. And we're going to create two macros or two global variables, and they're defined outside the main function. And for convention, they're usually capital so that people know throughout the code that they're global variables. So rows and columns. Okay, so now these variables are always going to be 2. That's the global variable definition. Let's create our main function. Int main, open parentheses, close parentheses, and of course return 0. Now let's create our vector, which is going to be called vec. And the way you create a vector is, first of all, you decide what is the type of elements that you're going to have. So let's start by doing an int, and we're going to say vector vec equals, or column, and is it going to be a vector or a matrix? If it's a vector, you call the vector header only once. If it's a matrix, you have to say it's a vector of vectors, and then it's a vector type int and the name. This is the format. Now notice that we are going to create a matrix called vec, or actually let's call it mat. It's going to be confusing, and a vector. So let's say vector type int and only one passing argument, and then we're going to call it v1. Okay, let's create an int, which is going to be number equals 0, and let's say for parentheses int I equals 0, semicolon, I less than my global variable row e plus plus, so go I plus plus. Then we're going to say something similar. So we're going to say for j in columns, for j in col, and j less than col, so it's not I anymore, it's j. Then we're going to say v1 dot push, should be one of, there you go, push, and the number. And we're going to say number 0, but next time number goes into the loop is going to be number plus 5. Okay, so it's going to be 0, 5, 10, 15, etc. And then at the end of this, let me see something here. So we have this one is, no, we did something wrong here, because this one should be closing here, and this one should be closing here. Right. Excellent. So now at the end of my for loop, I'm going to say vec, or mat in this case, matrix dot push back v1. So in this case, I'm pushing a number into my vector, but in this case, I'm pushing a whole row into my matrix. Let's try and run this code and see if we have any errors. Because I don't have, oh, I'm not done yet, I'm sorry. What we need to do next is to print it. So yes, let's see if I have any errors so far. So vector library, example 0. All right, so I do have an error. It says vector int. That was not what he wanted. And include vector using namespace standard. And then we have vector ints. Right, what is the issue here? Type int. Let's see, it seems that the error seems to be num. Okay, first of all, this one, yes, I know this error because I need to have semicolons here. Let's try to go over there. Okay. Oh, is it because I have two passing arguments? No, that's not it. It's two passing arguments because it's a matrix. Let me see. Is the vector also mistaken? Mat. Yeah, let's go ahead and comment this out. Let's see. Okay, so I have no errors there. Let's go back to my vector. And I say is vector type int, and then is int. What is my error? Should be within, the error is, okay, so I passed, oh, the error is because the library calls for a space. Okay, so it's, there you go. Nice. Okay, so now we can go back to the slides and see what else we need to do. Okay, we just need to print the matrix now. So we can read a vector. It's vector int. The space seems to be very important. Forgot about that. And then we're going to be doing mat, push the whole vector. Yes, no errors. Now we're back into the picture. So let's do let's copy this for loop and let's just print or see out there. So we don't need to push this anymore, and we don't need to push this anymore. We don't need to increment number anymore. What we need to do is, first of all, we can do a row. We're going to use another very nice function, which is vector dot size, and this will give us the size of the vector of the matrix in case we did not know that particular vector that was from a file or from a matrix or for input from the user. And then what we're going to do is, so the first for loop is going to go through the rows. The second for loop is going to go through the column. So we know that it's a vector of vectors. Therefore, what we need to do is in the first vector, in the first position, there's going to be a whole perpendicular row. In that position, what is the size of the vector that you put there? Right? So in the first position, there's a whole vector. Before it was only a number, but we decided that we're going to have a whole vector. Therefore, we have a vector of vectors. And we're going to say cout mat, which that's the other thing. In my example, I call it mat, not vec. So don't let me confuse you. Decided to call it mat because it's a matrix, even though it's a vector of vectors. I, comma j, and then we can do space, right? Or we can do cout end of line, sorry. Okay, what happens if I run it now? No errors. And then we have, let's see, what's going on here? Oh, I see why. The end of line. I'm doing the end of line after each value. That's not what we want. We want the whole vector to be displayed. Let's do it again. Okay, so we have mat I.size. First of all, let's see here. v1 push back a number in mat. Okay. So for mat and that size, let's see, what's mat.size? Before I do all that, cout mat.size. Let's create a comment block here that finishes here. There's a block of comment. I want to see what's my size here. 2. Okay, yeah, that's what I thought. It's 2 because it's a 2 by 2 matrix. And then what is mat 0 size? 2. Yes, okay, so that should be working. Let's see what kind of logic error I have. 0, 5, let's see. So for I equals 0 less than mat size, right, and j equals 0 less than mat size, do mat ij, right? I see what's going on. So let's go ahead and say, let's create this vector here inside the for loop, which is what the example wants me to do. So if you create it there and you run it, you have 0, 5, 10, and 15. 0, 5, 10, and 15. Let's see. I want to plot the same. And see out, end of line. Compile this and run it, and we should be able to see the output being the same as here, where if you notice from the code, first thing we have is declaring our matrix. Well, we called it mat instead of vic. So let's go ahead and get there. So our matrix is called mat and is a vector of vectors. Right now is dynamically initialized, so it has no particular size. The compiler knows that there's going to be a matrix or a vector of vectors, but doesn't know the size yet until we actually define it here. And one way to define it is with the push. So first, this vector is created with this for loop, so it's going to end up having the size of columns. It's going to be two dimension vector, or two vector with two elements. And then when you create a matrix pushing the vector, it's going to be 2 by 2. It could be 3 by 5, depending on the size of your global variables and your for loops, but this is 2 by 2. So when you print this case, it's gonna say, okay, you print the first case where I is 1 and j goes through all the nested loops, and in this case it's gonna print the first time 0 and 5. And that's because the first time we have 0, 5, and then when you go back, now 5 plus 5 is 10, and the second time is 15. So if you notice, this is doing the first time is pushing out what is in the first location of the matrix, and then is doing the second vector. But if you initialize your vector within the for loop every time, and you compile it, so close this and compile it, now you should be able to have matrix. And that is because before what we had was that is doing a vector, and each array is going to add to the same vector. So first we had 0 and 5, and the second time we pushed to increase the size of the same vector. Remember, this is dynamically allocating the size. Versus now, we said, no, we're going to say the size is fixed now, so we don't even need this line anymore. Truly, the line that is executing is here. This is what it's being executing every time. So every time the vector, this line. So every time the vector is being created again from 0, from scratch, is dynamic, and is being created as a 2 by 2 position, as a 2 element vector. Therefore, when you push this vector, you're gonna have 0 and 5. Sure, the second time number, the num int is 10 and 15, because we're not bringing it back to 0 within the loop. But this time I'm doing a square matrix because I am initializing my vector again every time, every loop. And so the difference is that when you comment out this line and uncomment this, or create your vector outside the for loop, When you run it, notice that I'm trying to get it to print here. The first loop is 0, 5. The second time is still dynamically increasing, so it's 0, 5, 10, 15. So it's 4 positions. Versus, as I said before, go back to this case where you create your vector within the for loop, which it will reinitialize the size of the vector every time. And in this case, you're going to be able to have a square matrix because every time the vector is going to have the same size. Going back to the presentation, we can have another example where in this case we want to print the matrix and we want to create a function which is called multiply matrix, and we can create a function also with the vector library. So notice that in this case it's going to be type double the matrix, the function, and is going to be a function that returns a matrix. So when I return D is going to be returning a matrix. So let's create a new file, and in this case we need to say include, we're going to say input output stream. It's because we're going to use cout. We're going to say include vector. This is another one, and I see that we're going to use printf, so we can use either the standard input.h or the classic C standard library, which is C standard input output, and using namespace standard because we're going to use the vector and the cout functions, or just for the puts. And then we're gonna say we're gonna create a main function. Where's my main function? Should be over here. My main function, let me see, we're gonna have a vector matrix and a vector yes, okay, so this is my main function. Let's start by the main function. So my main function is calling for int main, it's curly brackets, return 0. That's always what I have to write for my main function. So I have int n, which is not defined yet, it's just declared, and I have a vector of type double and space my first matrix called A, which is going to be size 4. In this case I'm going to restrict the size to size 4, and I have vector double, I'm going to create a matrix of ones. Okay, so I create a vector of type double, so in this case I'm creating a vector, and I said that it was going to be 4, 1.0. So it's, I said basically that is going to be, I forgot already how to sign, yes, 4, and position, every position is going to have a 1. Semicolon. Let's see by now if I have any errors. Oh, I can't write it yet because A is a function that is not declared yet. So let's go ahead and create B. And B is similar, but instead of zeros is going to be, instead of 1 is going to be 0. Okay, we have A and B created. So it seems like B is going to be multiplication of matrices. So multi matrix, and I'm gonna input A. Okay. All right. So let's go back to here and see what my mult matrix function does. So first of all, I need to create a vector double function, declare it, and it's going to be mult matrix. We said it was the name, and you declare it with input a matrix. So the input of my function, we said, is going to be a matrix. Therefore, it's going to be, we already know how to do this, it's going to be parentheses, column, not column, sorry. It's going to be vector, vector, matrix of doubles or floats or whatever it is, and we're going to call it matrix, right? And then curly brackets, open, close. All right, so we need to return a double, which is going to be return D, and we have to initialize D. It seems like D is initialized over here with size n and 2's. So let's go ahead and do that. Let's go ahead and do vector, vector, double, and call it D. Vector, the compiler doesn't like something here. Let's see what's going on. Vector, vector, double, mult matrix. Yes, that is exactly what I want. I'm getting an error. Why? Oh, this is not an error, it's a debug point. Okay, good. So let's create D. So first of all, it seems like I need my int n equals 0 for my size. And then I'm going to do n equals, call for the size from the vector function size, or another vector function, make the vector library, vector include vector, and then vector, vector, double D is the name of my library, of my matrix. And it says that D has size n and is going to be a vector double. Okay, so it's going to be a vector double. Let's copy this to make sure I don't have any typos. We said it was going to be size n and filled with 2's. n comma 2.0 column. Right? Excellent. So seems like now I'm ready to do my for loops to populate the matrix. So let me see. Let me see something here. I wonder if I just can create the for loops here. Okay. So for e, I'm gonna say int I equals 0 for I less than n, which is the size of the matrix, and I plus plus, create open close brackets, and let's do something similar for j. So instead of I, I'm going to say j, instead of I, I'm going to say j, instead of I, I'm going to say j, and within these brackets, I'm going to create more curly brackets. Okay, and here I'm going to say print f, and I'm going to say d equals %f, because I'm going to do a floating point or a double, and then it's going to be d I comma j, I comma j. Good. Return d. All right, let's go back to my main function. Let's see what I'm missing here. B is multiply A. Okay, so I also need an n, which is there. I'm going to do the same thing. N equals A size. I got the size. And I'm going to say printf A. Okay, good. Let's see if I have an error so far. So matrix function. Yes, I have an error, and it seems like D. I have an error in here, D. And what is the error with D? return was not declared. Oh, yes, I keep return D. Okay. So let's go over the code again. So vector, so I'm creating my function called multiply matrix. I'm creating my int n. So here n is equal to 0. N is going to be the size of the matrix, which I'm passing as an argument. And then I'm going to create a matrix called D, which initially is going to have that twos. And right here, I'm going to plot D and return D. Okay, so in the main menu, in the main function, I have int n, which is declared but not initialized. I have a matrix of 4 by 4 with ones, a matrix called A, matrix V has 4 by 4, it has zeros. So B equals multiply matrix A. So when I input matrix A into my function, it's going to return D, but D in the main function is called B. So then n is going to be the size of matrix A. I'm going to print A, and then I'm going to print B, which remember is D. So when I execute this, so compile and execute, I should be able to see my X code here. Excellent. So let's see. Going back to my code, I have that print n. I don't need to print n anymore. I'm going to close it again so that I can run it. Compile and run. Okay, so notice that first thing first is going to run from my main menu. So print A. Notice that this is A. So let's see. From the main menu goes to a function multiply matrix. So multiply matrix has a print statement which is going to print D, and D we said is going to be a matrix filled with twos. So this is D right here. All this is D. And then we're printing D, return it to the main menu, so it's the main function. So D is going to be called B in the main function, where we know that declarations can be variable from functions to main functions. So I could have called it D, but I didn't need to. Now it's going to be B, and it's declared here. And now I'm going to do, what I'm doing here is I'm printing A, and I'm printing B. So now I'm ready to write a function that will multiply my matrix A and B as I called my main function. Okay, let's go back to the slides and see that the homework now is going to be taking a 3 by 3 matrix and only outputting the corner positions. So in this case, we remove 2, 0, 4, 6, 0, 3, and we leave with 10, 7, 6, and 3. And this is useful because that's how you do the cross product or finding the determinant of a matrix, and this should be pretty straightforward.